Okay, today we're going to look at surface area of 3D shapes. Surface area is the total exterior two-dimensional surface area of a 3D object. And the 3D objects that we're going to study are going to be things that are regular, like prisms, cylinders, cones. We'll also do pyramids at the end of this unit. Let's start with the rectangular prism. Now, if you remember from junior high, you can take a rectangular prism and you can unfold it into what's called its net. It's sitting right now on this little length times width rectangle here that's kind of shaded. And if you unfold it, it's going to make a shape kind of like this, where the front and back make these two rectangles, so they'd be length by height, length by height. And then if you fold down the sides, which would be this face and this face, try to make this line and this line the same, it would be a width by height rectangle on either side. And then that just leaves the top surface, which could be attached anywhere. I'll put it here, but it's the same as this one. So these two are the same. They're both width by length. And these two are the same. They're both length by height. And these two are the same. They're both width by height. So I could say that the surface area formula is take a rectangle that's length by width, and a rectangle that's length by height, and a rectangle that's width by height, and then there's two of each of them. So that's kind of the way I think about the formula. And we won't give you that formula, so you'll have to kind of figure it out for yourself. Alright, let's try a couple of examples. First, the surface area here is, okay, let's see. Does it matter which one I call length, width, or height? No, not really. So I'll say that it's this face here is length times width. So I have two 5 by 9s plus 9 by 13 plus 5 by 13. So basically two rectangles like the ends, two rectangles like the top and bottom, and two rectangles like the left and right faces. And that, when I work out all that math, works out to 454 square inches. Okay, for example 2, oops, a little bit too low. Example 2 is even easier. A cube, all of the length, width, and height are the same length, so I could just say that it's a squared length, and there's 6 faces on a cube that are all the same, so I'll just times it by 6. So the surface area would be 6 times 5 squared, which is 6 times 25, don't need a calculator for that one, 150 square centimeters. Okay, so that's a rectangular prism. Let's move on to the close relative of the prism, the cylinder. Now the cylinder's net looks like this. It's a rectangle attached to two circles. The circles we should remember from junior high. The surface area for the area for a circle is pi r squared. And since there's two circles that are identical, I just times it by 2. This area here, though, we call it the lateral surface because it's the surface that comes up laterally from the base that it's sitting on. And we can call this a right cylinder because it goes up at a straight 90-degree angle from the surface it's sitting on. So this lateral surface, well, it's a rectangle, and all rectangles are length times width. But think of it this way. This distance here is the same as the distance around the circle. And I should know that as circumference, which is 2 pi r. So that's my length. And my width is the height of the cylinder. So just to kind of recap here, that's 2 circles and length and width of the rectangle that makes up this label part, if you want to call it that. Like it's a soup can, and that's the label of it. Alright, so for example 3, let's actually use our new formula. So the formula is surface area is 2 pi r squared plus 2 pi r h. And I'm going to plug in my numbers. So that's 2 times pi times the radius, which is 3 squared, plus 2 times pi times the radius, which is 3, times my height of 6. I should probably put that in a bracket. I always put brackets around numbers that were used to be variables that I plugged them in. And you can run this through your calculator right now. Use your pi button. I can actually show you that if you like. I'll use this calculator today. Okay, so we're looking at 2 times, and pi is its own button on this calculator. Please don't use 3.14. Use your pi button. Times 3 squared plus 2 times pi times 3 times 6. And there we go, 169.65. Another way I could have done that is I could have actually went, okay, well, hang on. This is all a multiply, so I'll just do the numbers first and then pi last. 2 times 3 times 3 is 18. So that's 18 pi. And this is 2 times 3 is 6. 6 times 6, that's 36 pi. And then I can add those together as if pi was an x or something. I could treat it like a variable, even though it's not really a variable. I know exactly what pi is. And I can say that that's 54 pi square feet. Now that's an exact answer, but the question does say round to 2 decimal places. So take your calculator and again go 54 times pi, and you get the same answer we got a second ago. Pretty cool. I like doing it that way. So that's 169.65 square feet. All right. Example 4 throws a bit of a curve at us. They don't give me a radius, they give me a diameter. So I have to figure out for myself that the radius is half of this. Half of 36 is 18. So back to the formula. Surface area equals 2 pi r squared plus 2 pi r h. Might tax my mental math a little to do this one the same way that I did that. So I think I'll just go right to my calculator and punch buttons. If you want to try punching buttons for yourself and see if you get the same answer as me, you could pause the video right now. But I got 12,214.51 square centimeters. So that's cylinders. Now let's talk about cones. Now cones are interesting. I asked my students during class if they could kind of guess or come up with a reasonable look at what the actual net for a cone is. And a lot of people looked at this curvy part. I mean, they all figured out that the bottom is a circle. But this curved part, the lateral part on this, was a mystery for some of them. Some people had seen it before. But basically, it looks something like this. It would be a circle attached to what is essentially like a half circle wedge. I think I've exaggerated the wedge a little bit. And it'd be attached at some point. And that's actually not quite exactly the way it should look. Actually, it probably would be that this should be a little closer to being a half circle. In fact, I want you to kind of imagine something. We're going to do a bit of a thought experiment with this. If I were to take this fanned out part that you have to kind of wrap around to make a cone, and I were to break this into triangles. Well, somebody in the class actually already mentioned when they looked at me doing this, said, well, they're not really triangles because this part's a curve. We'll talk about that in a minute. But suppose I take those triangles there and I start kind of reorganizing them. I take a pair of sort of imaginary scissors. That's how I draw scissors. And I cut along these lines. Now, okay, first of all, we call this distance here the slant height. We'll call it S. And that would be basically how long all of these sort of lines are. Or actually, maybe even better, all of the distances here are all slant lengths. So if I were to take all of these little triangles and cut them out, I could actually rearrange them like this. Something like that. And keep going until I've made it to the end. Basically, take this one out and put it here. Take this one out and put it here, etc. And keep doing that. Now, thought experiment. If I make these as short as possible, this curved part here would begin to look more and more like a straight line if I made a smaller and smaller curve. So eventually, this will approximate a rectangle. It'll approximately equal a rectangle. And that rectangle would have pi r for this length, because it's half of the circumference, and s for this length. So I have a rectangle and a circle, and my formula is pi r squared plus pi r s. And that's the formula that we're going to use for the cone. So let's try a couple of examples. Example 5. Surface area is pi rs plus, or actually I should say it's pi r, well, it doesn't matter what order it is, pi rs plus pi r squared. So the surface area is pi times my radius times my slant length of 12 plus pi times my radius squared. Okay, now again, I've already punched this through if you want to try it on your own and wait for me to kind of pause the video and give it a try. Turns out that you get 233.26 square centimeters. All right, example 6. All right, we've got a bit of a problem with example 6. They haven't told us how long this slant height is, and that's what I need for my formula, but they have told me this height here, so I'm going to need to do a Pythagoras. S squared, the slant height, is 7 squared plus 2 squared, which is 49 plus 4, so S is going to be the square root of 53. Okay, this number isn't my answer, so I'm not going to bother punching it and getting a decimal that I got to work with. I'm just going to go right to the formula. So it's pi r squared plus pi rs, and I have pi, radius is 2, pi, radius is 2, and my slant height I just figured out is the root of 53. Try punching that on your calculator the way it is. Again, pause the video if you want to try it and see if you get the right number. I got 58.31 when I rounded to 2 places. Okay, last example is a bit of a word problem. Surface area of a cone is 220. So here's our formula, pi r squared plus pi r s. I know the surface area is 220. The diameter of the cone is 10, which means the radius is 5. So I know that the r is 5. But I don't know what s is. So I'm going to use algebra to isolate s. So I'm going to move this to the other side by subtraction. And these two factors here are multiplying s, so I can divide both sides of the equation by those. And I'm going to get this, 220 minus, I might as well simplify that, 25 pi divided by 5 pi. Now when I did this with the class, I had some people who wanted to cancel those pi's and cancel 5 into 25, and notice you can't. This is all one term that has to be dealt with before I could divide by that term. Remember, you can only cancel factors, not terms. So I actually have to take out my calculator and run that through the calculator. Again, that's something you should try. Maybe pause the video, try punching buttons. Here's what you should get for the slant length. Okay? So that's cones. One more type of object that we got to talk about, pyramids. So these are called right pyramids, and they're called right pyramids because if I connect the center of the base to the apex, it's a right angle. Think about if that wasn't a right angle, the apex is over here or something, these would be very, very difficult to calculate, and that's a little beyond the scope of this course. The net for this thing opens up, there's actually one down here, opens up to look something like that. So really, it's 4 triangles that are identical and a square in the middle. So that's the way I think of this formula. The surface area here is the area of its base, which in this case is a square, plus the total lateral area. And in this case, the lateral area, so the area of the base is 1 square, and the lateral area would be 4 triangles. Am I on the screen? Yep. So my surface area is the area of the base plus the area of the triangles. All right, let's put that into practice down here. So the surface area here is the area of the base, which is a square, so it's 8 squared. Plus the area of one of these triangles is base, which is 8, times height of 10. But remember, the formula for the area of a triangle is base times height divided by 2. Oh yeah, and there's 4 of them, because there's 4 triangles that make up this pyramid. Alright, let's make our lives a little easier. 2 goes into 4 twice. So my surface area is going to be whatever 64 plus 80 times 2, which is 160 is. Don't need a calculator for that. 224 centimeters squared. Alright, so that's my first pyramid. This is a neat pyramid. This is actually a triangular base pyramid, and it's a special one. It's a regular tetrahedron, which means all 4 faces are exactly the same. They're all equilateral triangles. I was telling my students, you know, if I had made this problem up, I would not have been nice enough to give you this number. I think you should be able to figure it out for yourself. And it's not exactly 4.3. That's an estimation. You see, if it's equilateral triangles and they all have 5 for a length of the edge, then that height they're giving us, that slant height, is really the Pythagoras answer for when that's 5 and that's 2.5, because this would split that in half. So h squared plus 2.5 squared equals 5 squared, which means h squared is equal to 5 squared minus 2.5 squared, which means that h squared is equal to 25 minus 6.25, which means that h squared is equal to 18.75. So h is equal to the root of 18.75, and that, you can try that in your calculator if you like. The square root of 18.75 is, well, it's pretty close to the 4.3, sorry for the glare, it's pretty close to the 4.3 that they said it was going to be, but I like that my answer of square root of 18.75 is more exact, so I'm going to use that. So let's use our formula. Surface area is, well, hey, this is interesting, it's just 4 triangles. 4 times base times height divided by 2. So that's 4 times the base here is 5. The slant height is square root of 18.75 divided by 2. Again, let's make our lives easier. 2 goes into 4 twice. So I'm looking at 10 root 18.75, which works out to, let's get an answer for that, 10 times square root, sorry for the glare, 18.75, 43.30 meters squared. So there's first a square base pyramid, now a triangular base pyramid. Now here's a rectangular base pyramid. Now the difference between the square and the rectangle is, of course, this front triangle and this back triangle are the same, but the left and right ones are different. So I'm going to write that down as a note. 2 different triangle faces. So I kind of make myself a schematic. The surface area is the big rectangle it's sitting on plus 2 wider triangles and 2 skinnier triangles. You can kind of see it down here in the net. Bigger triangles, littler triangles, and a rectangle. So my surface area is the rectangle, 5 times 9. The big triangle is 2 times, and that'd be base times height divided by 2. And there's 2 of this triangle, which is base times height divided by 2. Again, make your lives easier. The 2's cancel. So my surface area, when I punch buttons, ends up being 117.3 meters squared. Okay, so that's example 3. Almost done. Check out that one. Okay, this is a great example. This is a neat little problem. I like this one. So I have a rectangular pyramid, and I need to know, if I'm going to find the area, I kind of need to know this line here and this line here. I need the heights of these lateral faces. And if I look on my picture here, this would be, say right here, this would be HA, and this would be GA. I need to know those lines. So how do I find them? Well, let's look at AG first, this line here, A to G. So A to G, right there, GA, connects to the height of the entire pyramid. which they tell me is 8 meters. And it makes a right angle with this line that goes to the base. And I know that the distance from here to here is 6. So this, because that's the center of the rectangle, must be 3. So AG squared is equal to 3 squared plus 8 squared. Do a quick Pythagoras on that. That's 9 plus 64. AG is the square root of 73. Okay, I'll use a different color to make things look a little better. I need this line now. And it's in this red triangle, which still has the same A to, I guess I should call this point F. Still has the same A to F height of 8. But now I'm looking for A to H, and this distance here is half of this 4, so it's 2. So AH squared is equal to 8 squared plus 2 squared. AH then, by the same math I did over there, is going to be the square root of 68. All right, I'm ready for the big formula. My surface area is a rectangle plus 2 wide triangles and 2 skinny triangles, which is 4 by 6 plus 2. The wide triangle has a base of 6, a height of this red line here, which is root 68 over 2. The smaller triangle is going to be, again, there's 2 of them, but it is 4 times root 73 divided by 2. Again, the 2's cancel. And when I run the math on that, I get a grand total of 107.65 meters squared. All right, check my blog for the homework, and good luck and practice hard.